everybody. Happy Friday. I hope you have a great day and a great 3-day weekend. I cannot wait to see you all on Wednesday because Tuesday you have a field trip. So, today we are reviewing proportional relationships that you learned about last year. We're going to talk about writing equations for a proportional relationship and comparing proportional relationships that are represented in different ways. So let's go ahead and let's look at our warm-up. And it's ladybug versus ant. So a ladybug and an ant are moving at a constant speed. The diagram with the tick marks over here show their positions at different times, and each tick mark represents 1 centimeter. The graph down here also shows their positions at different times. Line V is the ant, and line U is the ladybug. So the first question is who's moving quicker? Then how do you see that in the diagram with the tick marks? And then how do you see that in the graph? So go ahead, pause here, and come back once you're ready. So currently the ant is moving quicker. We see that in the diagram with the tick marks because once they actually start at every time, so the ant has a larger distance at any given time. Okay, so now let's see how we see that in our graph. So we see that in the graph by if we actually look at any distance. So we'll just look at this distance right here. At any given distance, the ant is going to have a shorter time since that's farther down. And having a smaller time for the same distance would mean that you are going faster. The ant has a shorter time at any given distance. It's kind of the opposite. So for the diagram with the tick marks, we looked at the time versus the graph, we kind of looked at a distance. So go ahead, get that down. And then let's go ahead and look at the next slide. So on this slide, it's just kind of like practicing writing equations that represent graphs. And we did this last year. So this is just going to kind of be a practice of that. So to be able to write an equation, we need to know the slope of the line. And so we've talked about the slope actually in the last unit a little bit. And remember, the slope is the rise over run. So how much did we go up versus how much we went over? And so to do that, we're going to look at our 2 points here. Or honestly, we could start at, I'm just going to start at 0, 0, and then go and see how much we went up and over. So to go from 0, 0 to this first point, we went up 14 and over 8. So we can write this actually in 2 different ways. So first one, it's always going to be y equals, but so we know that it's 14 over 8x, but 14 over 8 can also be reduced. We can divide both 14 and 8 by 2, and so that means y would be 7 over 2. Okay, so those both would be equations that fit this line. You can also turn 14 over 8 or 17 over 2 into an equation, or I'm sorry, into a decimal by dividing 14 divided by 8, 7 divided by 2. It's going to give you the same answer, and that's 3.5. So all of these are the same. It just really depends on which one you want to write down. I will say this one is going to be more helpful for the next activity. So go ahead and get these down and then come back once you're ready. Or no, get these down and then let's move on. That's what I'm trying to say. Okay. Now, next slide, we're actually going to do 2 slides at once. So for this slide, we are matching graphs to equations. So I've given you a bunch of graphs on this slide and a bunch of equations on this slide. So basically what we are looking at right now is we need to look at our slope, just like we did on the last one, because they're all going to be a y equals equation. The only difference is what is the slope of each line. So remember, the slope I would just go ahead and start at how much from 0, 0 to that point, and then create your slope that way, how much you went up versus how much you went over, and then match that to one of the slopes on the next line. We'll go ahead and do A together. So for this first graph, we go up 6 and over 24. So 6 over 24, both 6 and 24 can be divided by 6. 6 divided by 6 is 1. 24 divided by 6 is 4. So the slope of this line is 1/4. So we're going to now go back to our next slide, and y equals 1/4 x is going to match graph A. So that's what you're going to do for all of these. Obviously, there is not 20 graphs. Okay, there's a lot less than 20 graphs. There's only 12, so a lot of these spaces are going to be left empty. So go ahead. We did A. You have 11 more graphs. Find the slope, reduce the slope, and then match it to the equation. All right. So go ahead, try this, and come back once you're ready. All right. All right, let's go ahead and go over what the slopes of these lines are. So for B, we go up 6 and over 2. 6 over 2 is also just 6 divided by 2. So that one's just going to be 3. And then the other ones, I'm just going to go ahead, I'm going to do all of them that are going to be the same. So the other one that is also going to be a 3 is D. So up 30 over 10. 30 over 10 is also going to be 3. And then we have one more that's going to have a slope of 3, and that's going to be E. So up 12 and and over 4. So 12 over 4 is going to be 3 as well. Okay, so B, D, and E we are going to put in the table for right here. This has our slope of 3. Now let's look at the ones that are 7/2. So we actually have 4 of those. So the first one is going to be C. So for this one, we go up 175 and over 50. Both of these numbers can be divided by 25. 175 divided by 25 is 7. 50 divided by 25 is 2. The next one is going to be F. So this one we go up 7 and over 2. Or not up 7, up 7D and over 20. And so both of these can be divided by 10. And that gives us 7 over 2. Another one is actually going to be G. It's going to be actually G and H. So for G, we go up 28 over 8. And again, 28 over 8, they can both be divided by 4. And then H is going to be 325, 350 over 100. Okay. 350 over 100. Both of these can be divided by 50. And so that's going to be 7 over 2 again. All right, let's go ahead and put those in our table. C, F, G, and H. Okay, now we just have 4 more we need to fill in. Let's look at the ones that are 4/3. So it's actually going to be K and L. So K is 8 over 6, has a slope of 8 over 6. Both of these can be divided by 2. And then L is going to be 400 over 300. And both of those can be divided by 100. Okay, so K and L are going to be the same. And so then for the last one, that leaves us with I and J. So I is up a half over 0.2. So 0.5 over 0.2. This one we're actually going to multiply both numbers by 10, and that's going to give us the 5 over 2. J is 30 over 12. 30 and 12 can both be divided by 6, giving us 5 over 12. Or 5 over 2, my bad. All right, good job. Let's go ahead and continue on now. Make sure you have this table filled out. And let's move on to summer jobs. So Elena and Jada each made money by helping out their neighbors. Elena babysits. Her earnings are represented by the equation y equals 8.5x, where x represents how many hours she works and y represents how much money she earns. Jada earns $7 per hour mowing her neighbor's lawn. So we have 3 different questions. The first one, who makes more money after working 12 hours? How much more do they make? Number 2 is, what is the rate of change for each situation and what does it mean? And number 3 is, how long would it take each person to earn $150? So go ahead, pause here, try these, and come back once you're ready. All right. So, first of all, we want to know who makes more money after working 12 hours. Well, that's easy. Let's just go ahead and figure out how much they make after 12 hours. So we're going to find out how much Elena's going to make. And also Jada. So Elena's equation y equals 8.5x, where x is our hours. So we take our hours 12 and we multiply it by 8.5. That is going to give us 102. Jada makes $7 per hour. So we're going to do 7 times 12, and that's going to give us 84. So obviously Elena definitely makes more money in 12 hours. She made 102 versus 84. And so we just now need to say how much more she makes. And to figure that out, we're going to do 102 minus 84. And that's going to be 18. So our answer is not Claire, sorry, that's a totally different problem. Elena, and she makes $18 more. So it wants to know the rate of change for each situation. For Elena, that would be the 8.5. This tells us that Elena makes $8.50 an hour. Jada, her rate of change is 7, and it tells us that Jada makes $7 per hour. Oops. To figure out how much each person will earn, or how long it will take each person to earn 150, we're actually going to do the opposite, and we're going to divide 150 by our rate of change. So we're going to do for Elena 150 divided by 8.5, and that would give us 17.65. And then for Jada, we're going to do 150 divided by 7, and that's going to give us 21.43. Okay, awesome. Let's look at our next slide. Okay, so Han and Claire have summer jobs stuffing envelopes for 2 different companies. Han earns $15 for every 300 envelope he finishes, and this table shows Claire's earnings. So if she stuffs 400 envelopes, she earns 40, 900 would be 90. So who would make more money after stuffing 1,500? How much more money would they make? What is the rate of change, and who gets paid more in their job? So go ahead, try this, and then come back once you're ready. So for this one, there's so many different ways to look at it. I will just talk about what I did in the problem because it's the easiest to then answer all of the problems. So I went ahead and I found the rate of change. So for every envelope, how much did they make? To do that, we take the amount of money they make and we divide it by the amount of envelopes that they stuffed. So for Han, it's 15 divided by 300, and that gives us 0.05. For Claire, we could take either 40 or 40 and divide it by 400, or 90 and divide it by 900. It's going to give you the same answer no matter what, of 0.1. And so now we're going to use that to figure out how much each person would make. Stuffing 1,500, and so we're going to take the 0.05, multiply it by 1,500. That's going to give us 75. We're going to take Claire's 0.1, multiply it by 1,500, and that is going to give us 150. So Claire obviously made more. Now we just need to figure out how much more. So we're going to take 150 and subtract 75, and that's actually going to be 75 as well. So now we're going to say Claire, and she made $75 more. Now, the rate of change is actually what we have already found. So the rate of change for Han is 0.05, and the rate of change for Claire is going to be 0.1. Now what this tells us is how much they are paid per envelope. So Han gets basically 5 cents per envelope, and Claire will get 10 cents per envelope. Now we want to know who gets paid more in their job. Well, that's going to be Claire. And that is because she's paid actually double. She's paid twice the amount that Han is paid. Alright, go ahead and get that down. And we have just one more problem. So let's go ahead and move on. So now Tyler plans to start a lemonade stand and is trying out different recipes for his lemonade. He wants to make sure the recipe doesn't use too much lemonade mix, which is lemon juice and sugar, but he still wants it to taste good. So recipe 1 is given the equation y equals 4x, where x represents the cups of lemonade mix and y represents the cups of water. And this table represents recipe 2. So question 1, if Tyler had 16 cups of lemonade mix, how many cups of water would he need for each recipe? And then number 2, what's the rate of change again? And number 3, if he has a 5-gallon jug which holds 80 cups of water, and he has 16 cups of lemonade mix, which recipe should he use? So go ahead, try these, and come back whenever you're ready. Alright, so let's go ahead and start with number 1. So, if Tyler had 16 cups of lemonade mix, how many cups of water would we need for each recipe? So, first of all, we need our rate of change. I'm actually going to jump down to number 2 because we need our rate of change. So, for recipe 1, we already know our rate of change because it's in our equation. It's going to be 4, and that tells us that for every cup of water, we need 4 cups of, for every cup of mix, we need 4 cups of water. So, oh my god, stop. So 4 cups of water need 1 cup of mix. And then for number 2, recipe 2, we have to figure out what that rate of change is, what our constant of proportionality is. So our cups of lemonade mix times what would give us our cups of water, and that would be 5. So then we need 5 cups of water, need 1 cup of mix. So now we can use our rate of changes actually in number 1. And for recipe 1, we are going to do 16 times 4. And that is going to give us 64. So we would need 64 cups of water. For recipe 2, we're going to do 16 times 5. That's going to give us 80 cups of water. For number 3, if we have 80 cups of water and 16 cups of lemonade, we want to know which recipe we could use. And so we're going to actually work backwards on this one. So if we know the water and we're trying to figure out if the cups of lemonade would work, we're going to take our cups of water and divide it by our rate of change. So 80 divided by 4 is going to be 20. And then for recipe 2, we're going to do 80 divided by 5. And that's 16. So for this one, it's actually... Oh my gosh, the cats are playing. It's actually going to be recipe number 2. Because, please go away. Because we would use the exact amount of water and mix that is available. All right. Once you have that down, go ahead, and that's the end of the lesson. Ask the sub for the half sheet, and then you can also go ahead and start on the cool down. If you have any questions, feel free to email me. But I hope you guys have a great Friday and have a great weekend. See you guys on Wednesday. Bye.